In this tutorial, we will continue with the explanation of stamping toolbar. How engineers do it.
Before we start today's video, I would like to ask all my viewers to subscribe to my YouTube channel How Engineers Do It. So share the video among all of your friends and also hit the bell icon to never miss another update.
Next, we will see the bead stamping. For creating the bead stamp, go ahead and create a profile which is tangential. That means it doesn't have a sharp curve. We would also create a sketch which has a sharp curve here. And let's try to go for the bead stamp and try to apply this profile here for the bead stamp, and you will get the error that the profile should be continuous. Now let's try to select this as our profile, and this will be successful. So you understand that for bead stamping you need to have a profile which is tangential or which doesn't have a sharp curve. Click on the preview, and that's how you can create the bead stamp. Now let's go ahead and we will delete this bead stamp here. Now let's look at the curve stamping. Curve stamping is used to emboss features, emboss entities which are not connected tangentially. So let's look at the curve stamping. And as you can see here, the entities are not connected tangentially. So if you click on the sketch here, and if you click on the preview, you will be able to see how the curve stamp result looks like. Let's now look at the flanged cutout stamp. To create a flanged cutout stamp, let's firstly delete the existing features. Let's go ahead and create a sketch, and let's create circle and rectangle. So flange cutout stamp simply creates a cutout with a flange on the border. So if you go for the stamping flange cutout, just reduce the radius here, just go ahead and select the sketch here, increase the radius by around 4 mm. To create a flange cutout stamp, create a close profile here by going to sketch and simply creating a close profile and going for the flange cutout stamp. Flange cutout stamp simply makes a cutout with a flange on the border entity. So as you can see here, this is the border, and at the border you got a flange. Now let's look at how we can work on the lower stamp. To create a lower stamp, let's firstly quickly create a sketch. Lower stamps are used basically for making ventilation openings. So as you can see, we have a rectangular profile there. Let's go for stamping and lower stamp. Select our profile, and next select the opening line. Now if you click on preview, you will be able to see that an opening is being created here, and this serves as a ventilation. So if you increase as I've mentioned before, you can increase or decrease the height and other values in the parameter spinners. And that's about the lower stamp. Now let's look at how we can create a bridge stamp. Bridge stamp is used to create features for holding the component. So firstly, in order to create a bridge stamp, we need to have an insertion point. We will create the insertion point by going to the Sketcher workbench and exiting the Sketcher workbench. Now we have an isolated point on the sheet metal wall. Next, let's go for the bridge stamp. And once you click, you won't be getting a window. To get the window, firstly we need to click on the point and then on the sheet metal surface. And once you do that, you will be getting the option of bridge stamp. You can reverse the direction of the bridge stamp, and you could also increase or decrease the height, length, etc. Once you click on the preview, you'll be able to see the result of a bridge stamp. As you can see, this could be used to lift the component or keep the component down. Now let's look at how we can do the flanged hole stamp. Flanged hole stamp is used to create a hole on a sheet metal surface with a flange. Let's first delete the bridge stamp we have here, and the input that we require for creating a flange hole stamp is a sheet metal surface and a point. So let's go ahead and select the flange hole stamp, and let's click on the point and the surface as we have done before, and then click on the preview, and you can see a hole is being created with a flange. As you can see here, we have an option to either disable or enable the cone, and if you disable the cone, you won't be getting a cone. If you enable the cone, you can see the cone as well. And as I've mentioned before, you can increase or decrease the values of radius and height, etc. By using the parameter spinners here. Click on OK. Now let's look at the circular stamp feature. To do that, let's delete the previous flange hole stamp, and for circular stamp we need a sheet metal surface and a point as an input. Circular stamp simply creates a circular embossment on a sheet metal surface. Go ahead and select the circular stamp and select the point as the input and the surface, and then click on the preview to have a look at the preview. And as I've mentioned before, you can increase or decrease the height value and other parameter spinners, and this output that you can see for the circular stamp is purely dependent upon the placement of the point and all the different parameter spinners, as you can see here. Click on OK. Now let's look at the stiffening rib stamp. Stiffening rib stamp is used for stiffening the sheet metal components. For example, I will create a wall on edge, and make sure that in the sheet metal parameter your radius for the wall on edge is bigger enough to see it in this way in your screen. That is, you need to increase or decrease the bend radius here. And then for stiffening rib stamp, we generally create it between a bend and that appears on the cylindrical portion of the sheet metal. Go for the stiffening rib stamp here and specify the outer cylindrical surface, and then you can specify the length, the radius to angle, etc. So let's just try to increase or decrease the length values to maybe 70 mm. As you can see, Oh, this 70 mm won't work because it coincides with the hole that we have created previously. So let's go for 60 mm maybe. 60 mm also coincides with the hole that we have created previously. Let's go for 30 mm. Click on preview and you can see that a rib which stiffens the sheet metal component is being created between the two sheet metal component. Click on OK. And let's finally look at the dowel stamp. For creating a dowel stamp, you need to have a point and a sheet metal surface. Let's go for the dowel stamp and select the point as the first input, and you need to make sure that you're selecting the surface of the sheet metal which is opposite to the point, to the place where the point is located. So as you can see here, the point is located at this surface, and the surface that you need to select next should be the opposite surface. Now if you have an option to increase or decrease the diameter value, and you could also reverse the direction of the dowel stamp here and click on OK. So there are the different options that comes in the stamping toolbar in the generated sheet metal workbench. Let's see what comes next.